Today we are hitting a half century in our discussion of these physics problems, because today's number is physics problem 50. This also from this year's advanced paper. Topic involved is diffraction and error analysis, but basically you will take it as an example on error analysis, because diffraction is not in the advanced syllabus, and they have quoted the formula, and using this formula when you do make some calculation, what will be the error involved? That is basically that is the question. Now here also the term absolute error, this word absolute error is somewhat ambiguous, because judging by the answer given, it is the maximum possible error for the given measuring instrument, least count of the measuring instruments. What is the maximum possible error that can occur in this experiment, where formula is also given. Now, by data value of B is what we want. That is the slit width. Slit width is B here. D is described as distance between the maximum diffraction maximum of the nth order. Lambda is the wavelength, and capital D is the distance between this distance between slit and the screen, that is capital D. So by data value of B is equal to m lambda into capital D by small d. That is the given from the given formula. This is our D formula is that. So, and also D is required for a certain small d and capital D, both are given. So the D is equal to m is 3 given. Lambda is the wavelength. Wavelength used is given as 600 nanometers. 600 into 10 minus 9. Capital D is 1 meter is given. That is capital D. Suppose for convenience I am putting it in centimeters. In centimeter. Divide by 100 to make it SI unit. So meter. Small d is given in millimeters. So d in millimeters. Millimeter. Given value we can substitute. But to make it SI, we multiply by minus 3. So this is the B for general formula for B. But this is in meters. You will get it in meters, B. But answer is required in micrometers. So we multiply by 10 power 6 micrometers. So meter is there, not the unit. If you simplify this with the proper values with the values of capital D and small d, you get the slit width in meters, no, micrometers. So after clearing some space, I will continue. We are going to calculate the maximum possible error. So we got an expression for B as equal to this expression, which you can further simplify as B is equal to if you simplify this, 10 minus 9 will cancel with this. 100 also you can cancel, so that you get 18 times d by small d. 18 times capital D in centimeters upon small d in millimeters. That is our general expression for B in micrometer. The resulting number will be in micrometers for B. And because the question is based on the error in micrometers. So we get that true value for B is equal to, for the given 18 times, capital D is given in meters, 1 meter given, so 100 centimeters. Small d is given as 5 millimeters, so 5. This is the true B. Now we find the errors involved. Lower value of B that you can get from this divide in this experiment is B lower limit. B true value. And B upper limit. These three quantities we are going to compare. Lower limit must be less than the true value, upper limit must be more than the true value. So what is this implies B lower value is 18 is fixed. For lower limit, we put the lower experimental value of D, which is 99, 1 millimeter less, 1 centimeter less, 99. We to minimize this, we put the upper limit of small d. Small d upper limit of 1 millimeter error means upper limit can be 6. Less than true value 18 times 100 by 5. Less than the upper limit. The upper limit is 18 times. For upper limit, we add the error, 1 centimeter error becomes 101. We minimize this 1 millimeter error means it becomes 4 minimum, lower. So this is the upper limit and lower limit we are getting like this. So this error, the error involved with the lower limit is, lower limit error is delta B1, call it as delta B1. Delta B1 is equal to this minus this. 18 times 100 by 5 minus 99 by 6, which gives us 18 into this fraction will be 105 by 30. Now the upper error, the error with the upper limit is for which we find the difference between these two. This two limit is delta, call it as delta B2. Delta B2 is equal to 18 times, this is larger, 101 by 4 minus 100 by 5. Which gives us 18 times 105 by 20. So comparing the two, this is denominator is 30 here, denominator is 20, other numbers being same. So it is clear that this gives us a larger error. This is giving us a larger error. So we can say delta B2 is larger than delta B1, and that is the required answer. So we can say delta B2 modulus is larger than delta B1 modulus. Implies delta B2 is the required error. Delta B2 represents a larger variation. Represents larger variation. Larger variation. It is equal to 9 into 10.5. 9 times 10.5. 9 times, simplifying that, 10.5 equal to 94.5 micrometers. So this gives us the maximum possible. Let me repeat the last step again. Delta B2 being larger, and we are getting the value as 9 times 10.5. This is giving us 94.5 micrometers. So that is the larger possible error in using this in this experimental setup. So we can give the final numerical answer as 94.5. Numerical answer 94.5 is already in micrometer. So this you can express as the numerical answer, 502 decimal places. Unit is micrometer, but you need only numerical answer only you have to give.